Hi there everyone, how are you? I hope you're having a good day. In this video we're going to talk about the states of matter. There are three main states of matter, although that is not the whole story. Before we go on to see what they are, do you already know what the three states of matter are? Just have a think and we'll go on and find out on the next slide. Of course, the three main states of matter are solid, liquid, and gas. And the atoms in these three different states have different amounts of energy, and so they behave in different ways. And that means that the matter that all things are made out of looks different and has different qualities. To demonstrate this, water is a good example to look at because we are all familiar with the three different states of water. So let's start by talking about solids. Atoms or molecules in a solid are fixed together so they cannot move around. A solid holds the same shape and has a fixed volume. So you can see in the diagram the blue cube sits inside the larger cube and it does not change shape because it is solid. You can also see all of the atoms or molecules in a solid fixed together in a shape that holds its form. You probably know what word is going in the bottom there, but water in its solid state is called ice. As you get further into chemistry, you will find there are many different types of solid and these have different chemical qualities. For today, I'm just going to mention some of the names and examples, but that's where we're going to leave it. Some of these different types of solids are ionic solids like salt or copper sulfate, metallic solids like gold or steel or iron, crystalline solids like diamond, ruby, or quartz, molecular solids like ammonia or methane, or amorphous solids like rubber or glass. There will be other types of solid, and some of the types we mentioned here will cross over with each other. For example, salt is made of crystals, but it is still an ionic solid. The next state of matter is liquids. Atoms or molecules in a liquid have slightly more energy than those in a solid, so although they are still connected together, the bonds between them will form and break all of the time, and the atoms will move around each other. So, while a liquid has a fixed volume, its shape will change to fit the container that it is kept in. In the diagram, you can see that the liquid fills the bottom of the larger cube. It changes to fit the shape of its container. And we can also see those molecules moving around each other. They are not held in the same strict shape that a solid is. Ice is the solid form of water, and ice melts into liquid water at a temperature of 0 Celsius. You might often think of it as water freezing into solid ice at 0 Celsius, but the same is also true in reverse. And something you might be quite surprised to learn is that cats are liquids. Did you know that? It seems kind of strange, doesn't it? But liquids will change their shape to fit the container they are placed in. So as we can see from this picture, cats are clearly liquids. Liquids also have different forms we can talk about, although this is less different types of liquid and more different ways of mixing them together. A pure liquid, like distilled water, has absolutely nothing else in it. It is just the liquid and that is all. A solution, like salt water, is a liquid that has a solid dissolved in it. On the other hand, a suspension, like pepper in water, is a liquid with particles or grains of solid, or bubbles of another liquid floating in it. A colloid, for example powder in water, is a liquid with another solid or liquid in it, but the particles this time are too small to be seen. If you take flour and mix it into water, you end up with something that looks like milk. You can no longer see the tiny particles of flour, although they have not dissolved into the liquid. And finally, emulsions, like milk, are a special type of colloid with two or more liquids that normally do not mix, but because of the chemistry, they are now mixed into what we call an emulsion. Talking of things dissolving, do you know the other vocabulary for when we dissolve something? For example, the solid that will dissolve in a liquid can be called the solute, and the liquid that can dissolve a solid can be called a solvent. And our third main state of matter is gases. Atoms or molecules in a gas have so much energy they can escape and move around on their own. A gas will therefore change not only its shape, but also its volume to fill the container it is in. In the diagram, we can see the molecules have spread out evenly through the cube or through the bottle, and they have fit the shape of the container they are in. We can also see this picture of a kettle boiling, and that is a gaseous form of water. What is this gaseous form called? Water boils into steam at a temperature of 100 degrees Celsius. But wait, on the previous slide we saw this picture, and I suggested that this is gaseous water, but it is actually not. Steam is water vapor. A vapor is a mixture of gas particles, which you cannot see, and tiny droplets of liquid, which you can see. A true gas will be invisible. For example, the clouds that we see in the sky are made of water vapor, but there will be an awful lot of gaseous water even in what we see as a clear blue sky. Those are the main three states of matter, but there is a fourth state that we know quite a lot about. It is a very high energy form of matter. It is like a gas, but the atoms or molecules are carrying electric charge. Do you know what this fourth state of matter is called? The fourth state of matter is called plasma. Extreme heat or very strong magnetic fields can create plasmas. In fact, plasma is the most common form of matter in the entire universe. All stars are made of plasma, but we do not see it much in everyday life, especially before the science of the modern world. But in fact, we are still not done. Other states of matter have been discovered. They are usually found in very extreme conditions like high or low temperature or pressure, and we are still learning about all of them. Some examples of these further states of matter are superfluids, Bose-Einstein condensates, quark-gluon plasmas, and something which is called degenerate matter, which is found in neutron stars. Again, I'm just introducing these names, but we are not going to go into what any of these different states are at this point. But just knowing that these other states of matter are out there shows us that we still have a lot to learn about the chemistry and physics of matter. And that is where we will leave it for today. We've looked through the three main states of matter and what the differences are between them. We've also had a quick look at other states of matter that you might be interested to know about. If you've enjoyed this video, then please like it, and you could also share it with a friend. Ask any questions you would like in the comments, and why not subscribe to MYEPScience so you can check out some of our other science videos and those coming soon. Thanks for watching, and bye for now.